Okay, so chapter is electronics. In electronics, each device has three parts. One is sensing device. Number two is processor. And number three is output device. So sensing device, processor, output device. So these are very, very important for electronics. Now, sensor, which is very, very important, is LDR thermistor. We have done this in O level. Now we have to study the processor. Now, processor in our syllabus is called operational amplifier. And in short, it is called op-amp, operational amplifier. What is this? It is an integrated circuit of electric components like diode, resistor, capacitors, etc. At least 20 in number. All are connected with each other in different combinations. Means series or parallel at a silica plate. Plate means the silica is covered by a plastic insulated box with at least 5 terminals. Now look, this operational amplifier op-amp is an integrated circuit of electric components like diode, resistors, capacitor. At least they are 20 in number. They can be more than 20. All are connected with each other in different combinations like series and parallel at a silica plate. And the plate is covered in a plastic box with at least 5 terminal. And due to this integrated circuit in the market, it is also called IC. But in physics, it is called operational amplifier, op-amp. So theoretically, we will not write it IC, but practically in the market, it is named as IC. Okay, now this plate, or this operational amplifier, looks like a box with 5 terminals, 1, 2, 3, 4, 5, sometimes like this. Any shape. But in physics, we have to use its symbol and its symbol is like this. And its terminals are number 1, number 2, number 3, number 4, and number 5. So these are 5 terminals. Now, in electronics, resistance is known as impedance. And the advantage, you can call it efficiency, is called gain, and also the ratio. And the range of frequency in electronics is called bandwidth. And response is called slew rate. So we have to remember resistance is impedance, advantage is gain, mean the efficiency, and the range of the frequency is called the bandwidth, and response is called slew rate, and the fault or the faulty instrument is known as saturated. In electric device, in electric appliance, input, output will be voltage and current. In all electrical appliances, work on the voltage and current, but electronic equipment, electronic devices only work on the voltage. There is no current in the electronics. And input is in the voltage form. Supply is also in the voltage form. And output also in the voltage form. Mean there is no space for the current in the electronics, but electric devices work on both voltage and current. In electronics, only voltage. So that's why there's a difference between electrical component and electronic component. So two different departments, electric engineering and electronic engineering, and sometime it is merged and called electroelectronics. So in the electric appliance, there will be a closed circuit to allow the current to flow. And in the electronics, there will be open circuit to stop the flow of the current. Now, come to this. Number 1 terminal is called positive supply voltage. And it is represented by plus Vs. Number 2 terminal, this one, is the negative supply voltage. And its symbol is negative. Mean these two terminals are connected with the battery to switch it on. That's it. So we have to switch the electronic circuit first. So these two terminals are connected with the battery. So these terminals are called supply. One is positive, other is negative. So the positive terminal of the battery connected here and the negative terminal of the battery connected here, just to switch it on. Now, the number 3, this one, is called non-inverted input terminal. And it is represented by V positive. So this is V positive, positive at the top of the V, because it doesn't mean the positive voltage, just as simple. It can be positive, it can be negative, it can be DC, it can be AC voltage, direct voltage, alternating, it can be anyone, but it is non-inverted input terminal. And number 4, this one is called inverted input terminal, and it is represented by V negative. So V negative. Now do remember, these two voltages are out of phase to each other. If this voltage is like this, then at the same time, this is the cycle of this voltage. Look, 180-degree phase difference. So the phase difference is 180-degree mean pi radian. So these two inputs are at the angle of 180-degree phase difference. And this number 5 is called output voltage terminal. And it is represented by V naught. So it has 5 terminals: positive supply voltage, negative supply voltage, non-inverted input voltage terminal, inverted input voltage terminal. Both are at the phase difference of 180 degree, and this is output voltage terminal. So supply, input, voltage, all are in voltage, not the current. And do remember, this output voltage directly proportional to difference of two inputs voltage terminal. Difference of these two voltage and this output both are directly proportional to each other, and the maximum output from the output terminal is equal to supply voltage. The maximum output which can be gained from any operational amplifier is plus minus supply voltage. If output during calculation is coming greater than any supply, so it's wrong. It means your operational amplifier is saturated, mean it cannot deliver output greater than supply. The maximum end is the supply, and after this it is called saturated, mean there is a fault in it. And do remember, if non-inverted terminal voltage is greater in magnitude than inverted, mean for example, this is 5 volt, this is 2 volt, then the output will be positive in polarity. And if non-inverted is smaller than inverted in magnitude, then the polarity of the output will be negative. Now the properties of ideal, and then here the practical. operational amplifier. Number one, it was assumed that the resistance of these two terminals must be infinity. But the resistance in electronic is called impedance. So impedance of input terminal must be infinity because we don't require any current. To stop the current entering the op-amp, the impedance of these two terminals must be infinity. But practically, when it is made and its resistance impedance is calculated, it was approximately 10 power 6 to 10 power 12 ohm. This is also too much. Number two, ideally, it was assumed that impedance of output terminal must be 0, but practically it was 100 ohm because this output terminal is connected with other electric components, and electric components work on the voltage and current. That's why after this amplifier, the resistance is 0 because we have to move the current. We have to move the charge to switch on the electric devices. And number three, gain. And gain mean open loop gain. Open loop gain. Why open loop? Because no current. Gain mean efficiency, output. Open loop gain must be infinity, mean the advantage. Mean gain is the ratio between output voltage and input voltage. Open loop gain must be infinity, but practically it was 10 power 5 for direct voltage. Not infinity, it's limited. How much? 10 power 5, it's too much, 100,000. And number four, the bandwidth of operational amplifier input voltage must be infinity, mean there is no limit for the input voltage. All frequency voltages are accepted by it, because the bandwidth means the range of the frequency for the input voltage is infinity. All frequencies are accepted, but practically it is not infinity and still undefined because gradually improving. Gigahertz, terahertz, it's gradually improving. So we can't say that this is limited. And number five, the last, the response is very high, which is called the slew rate. So its slew rate is infinity, mean its delay rate is 0. If there is fluctuation in the input voltage, so there will be no delay in amplification, in processing. But practically, there is 10 microsecond, sorry, it is 10 volt, 1 microsecond. Mean if 10 volt fluctuation, then 1 microsecond delay. So 1 microsecond per 10 volt. If the voltage fluctuates by 10 up and down in magnitude, then it delays for 1 microsecond. Mean it's slew rate, not infinity. So these are the 5 properties for the ideal operational amplifier, and it's practical.